Welcome to the Curious Culture Club, where we explore the universe's most captivating phenomena. Today we embark on a journey through the cosmic life cycle of stars. We'll voyage from the birth of stars in vast molecular clouds, through the fiery furnace of their existence, to the explosive finale of their death. We'll marvel at how these celestial bodies, through their birth and death, play a vital role in the grand cosmic narrative. So fasten your seatbelts as we journey through the birth, life, and death of stars. Our journey begins in the vast, dark expanses of space, home to enormous molecular clouds. These are not silent, empty spaces, but lively nurseries where the birth of stars takes place. Imagine these molecular clouds as vast regions filled with dust and gas, cold and dark, stretching across many light years. When the conditions are just right, a part of this cloud begins to collapse under its own weight, a process driven by gravity. This collapse is not a gentle one, but a dynamic, chaotic process that forms a swirling, spinning disk of material. At the heart of this disk, a protostar begins to form. This baby star grows denser and hotter, its mass increasing as more and more material from the cloud falls onto it. Eventually, the pressure and temperature in the core of the protostar become so high that nuclear fusion begins. Thus, from the dust and gas of these vast clouds, a star is born. Once born, a star embarks on a life determined by its mass. This life is a cosmic journey of transformation and energy production that unfolds over millions, even billions of years. The journey begins with the main sequence stage, where a star spends the majority of its life. During this period, a star's core is a bustling hub of nuclear fusion where hydrogen atoms collide and combine to form helium. This process releases a tremendous amount of energy, which we perceive as the star's light and heat, but this energetic fusion is more than just a light show. It's also the force that keeps a star from collapsing under its own gravity. The outward push of fusion and the inward pull of gravity are in a constant tug-of-war, maintaining a delicate balance that shapes the star's life. As a star exhausts its hydrogen fuel, it begins to evolve. For stars like our Sun, this evolution leads to the red giant phase. In this stage, the star's core contracts, heating up and causing the outer layers to expand and cool, giving the star a reddish hue. For more massive stars, the journey is more dramatic. They undergo a sequence of nuclear reactions, fusing heavier and heavier elements in their cores. Each stage of fusion generates less energy than the last, and the star's gravity begins to win the tug-of-war. Eventually, the core becomes so dense and hot that it can fuse iron atoms. But iron fusion doesn't release energy, instead it absorbs it. Suddenly, the balance tips. Without the outward push of fusion to oppose it, gravity causes the core to collapse, triggering a supernova explosion. And so, a star lives out its life in a delicate balance of forces, illuminating the cosmos with its energy. From the main sequence to the red giant phase and possibly beyond to a supernova, each stage of a star's life is a testament to the power of nuclear fusion, the force of gravity, and the cosmic dance between the two. But all stars, no matter how bright, must eventually meet their end. Like a grand finale, the death of a star is a spectacle of cosmic proportions. Massive stars, those with a mass many times that of our Sun, explode in a cataclysmic event known as a supernova. This stellar explosion is so bright that it can outshine an entire galaxy, if only for a brief moment. From the remnants of these supernovae, fascinating celestial bodies emerge. Some form neutron stars, incredibly dense objects about the size of a city but with a mass greater than our Sun. Others collapse under their own gravity to form black holes, regions of space where gravity is so strong that nothing, not even light, can escape. But let's not forget about the less massive stars. These stars, including our own Sun, meet a more serene end. As their fuel runs out, they cast off their outer layers, creating a beautiful display known as a planetary nebula. This nebula, rich in heavier elements, serves as a cosmic nursery, providing the raw materials for the birth of new stars and planetary systems. Whether it's through a fiery supernova or a peaceful planetary nebula, in their death, stars give birth to new celestial bodies, including stellar mass black holes, the end result of the most massive stars. And so, in death, a star seeds the universe with the materials for new stars, continuing the cosmic life cycle. Our journey through the life cycle of stars brings us back to where we started. We've witnessed the birth of stars from vast molecular clouds, their radiant life stages fueled by nuclear fusion, and their awe-inspiring demise, leaving behind celestial remnants. Whether forming white dwarfs or fueling the birth of new stars and planetary nebulae, the cycle perpetuates. From birth to death, each star plays its part in the grand cosmic dance, a dance that continues to shape the universe as we know it.